jigsaw puzzles can be a lot of fun. Right? Jigsaw puzzles are the process. They're these little pieces you can put together, and you figure out this entire puzzle by looking at the pieces and seeing how they fit to other pieces. And then you put them together, and after you're able to put all the pieces together, you get a beautiful picture. Well, in this video, we're going to see how the Earth is a lot like a jigsaw puzzle. In fact, it was how one person was able to put the pieces together that has actually created almost the entire field of geology and made us be able to understand volcanoes and earthquakes and all sorts of different factors. In this video, we're going to be doing three very specific things. The first thing we're going to do is we're going to describe this gentleman named Alfred Wegener and his hypothesis that he called Continental Drift. Then we're going to identify key pieces of evidence for continental drift. And finally, we're going to compare and contrast continental drift with the modern idea of plate tectonics. Alfred Wegener is a personal hero of mine. In fact, first off, I really like Alfred Wegener because he has one of the coolest middle names ever. He was born Alfred LOTHAR Wegener. Lothar, that just sounds to me like a really awesome rock band. Ladies and gentlemen, we're Lothar! Maybe not. But Alfred was born in 1880 in Germany, and his family, his mother worked at an orphanage, and his father was a pastor. And from a very early age, Alfred showed that he was excellent at science and math, and was really interested in nature. After doing some basic grade school and high school, he entered into Humboldt University there in Germany, where he studied astronomy and meteorology. He was very passionate about climate and how these things all work together. After graduating, he went on expeditions. He went to Greenland a couple times. He went to explore the Caribbean and down almost to the Falkland Islands. He did all these things trying to figure out how weather and climate affected each other. In the turn of the century, around 1900s, early 1900s, World War I broke out, and Alfred was called back to work with the Germans as an reserve infantry officer, and was actually called up to active service. And in World War I, he was wounded multiple times, actually twice. Because of that, they actually called him away from front lines, and he was recuperating in a hospital where he was going to be focused now on simply looking at weather. But while he was injured is where he started to see something that would change the world. Alfred, laying in a hospital bed, looking at the map of the Earth, had an observation. Now, it's an observation that I'm guessing now we have all the time. He noticed something. Looking at a map of the world, if you took South America and you took Africa and you were able to cut them out, they fit almost perfectly together. He also started to look at some of the other continents. He saw that Madagascar fits up against Africa. Pieces of India actually fit up against Africa, and other portions of Australia and South America, Antarctica, they all kind of fit together in what he called as a supercontinent. Now, at first he thought this was a genius. He thought he had a great idea. How could anyone argue with this? Look, they all fit together. He also found other pieces of evidence. He found that there were fossils of reptiles and plants that were on separate continents. How could they possibly, if they can't swim across an ocean, be on different continents? He thought, well, you know what had to happen is all the continents were together in a supercontinent and then were pulled apart or drifted away. He called his idea that the continents drifted around continental drift. So the idea of the continents moving is continental drift. Now, he presented this idea at a symposium, a gathering of geologists, and he expected that his new discovery would be heralded as a linchpin, a key to all new geology. It didn't turn out that way. Alfred spoke and presented his paper, and largely, Alfred Wegener was laughed at. They thought his idea was crazy. How was it possible that giant pieces of rock, the continents, millions of tons of granite, were able to move or drift? It didn't make sense. Even Alfred had to admit he had no way of knowing how the continents moved. He just was able to say that they obviously did move. They fit together. There were plants on both continents. There were reptile fossils on both continents. As a result, Alfred LOTHAR Wegener was largely laughed at. He was largely considered a crank and was pretty much ostracized and kicked out. Basically like, you're no longer a part of our group of the geologists. They thought of him as a crazy person. His idea as something called pseudoscience, or not scientific. He was kind of exiled. He was kicked out, and he ended up going to Greenland, one of his first loves, where he manned an expedition, a service station, to monitor the weather of Greenland. While he was there in 1930, a group of Swiss weathermen, Swiss meteorologists, were stranded out on the ice. And Alfred, deciding that they needed help, went out to rescue them. Now, as he was out rescuing them, the Swiss team was actually able to make it back to base camp. But Alfred was not. He was stranded on the ice. He ran out of food, and eventually he starved to death. He died as a crank, as an idea that was not accepted, the fact that the continents could not move. His ideas were a laughingstock of the geologic community. Geologists thought there's no way that Alfred LOTHAR Wegener. That wasn't until 1960. In the 1960s, right after World War II, there was an abundance of a brand new technology. This gentleman, Harry Hess, he was a World War II captain, was on a ship called the Cape Johnson, the USS Cape Johnson. And it was equipped with this brand new technology called sonar. And sonar was able to send out sound waves. It would bounce off the bottom of the ocean and come back, and you could actually map out the ocean this way. And so Harry Hess was taking his boat over from across the Atlantic over to Europe, and he found something very interesting. You see, in the middle of the ocean, he found a line of volcanoes. He called this the mid-ocean ridge. There was a line that traveled all the way up the Atlantic, right in the middle. He then actually collected core samples. Harry Hess was an excellent geologist before he actually was at Princeton. And so he took core samples and was able to see that the rocks on either side of the volcanoes were younger than the rocks on the outside. Based upon this, he called it the mid-ocean ridge and was able to figure out that they're actually pushing the ocean apart. These line of volcanoes, the mid-ocean ridge, were shoving the continents away. This new idea of the continents being pushed by the mid-ocean ridge was called plate tectonics. And as we now can see, that Alfred was right. The continents originally did work together and were called a supercontinent, which we now call Pangea, or across the Earth, and then were pushed apart by mid-ocean ridges. Alfred died a laughingstock, but he was right the entire time. Now, there was some things that Alfred was wrong, and so his idea of continental drift is a little bit different plate tectonics. Right? And let's take a look. We can see some of the differences here. Now, first off, they both had the idea that all the continents were together and were pulled apart. We have the idea that it happened slowly over time. Both of them, right? Alfred's idea thought they just drifted and kind of floated away, whereas Harry Hess and plate tectonics they're being pushed away. In continental drift, it's just random. It just happens. They float around, just like if you set out a buoy out in the ocean, it might float and move around. Whereas in plate tectonics, that mid-ocean ridge is very specifically pushing them apart. But in the end, Alfred was right. The continents move. They were once all together and then were pushed apart. So what did we talk about in this video? Well, we did a couple things. First, we saw who Alfred LOTHAR Wegener was and his hypothesis of continental drift, that the continents were once together and then kindly randomly floated away. We saw that he had some evidence. He saw that the continents fit together perfectly, almost perfectly, and that there were fossils of plants and reptiles on two different continents separated by giant oceans. We also saw that Alfred died a laughingstock, and his idea wasn't even accepted until Harry Hess in the 60s was able to prove that there were these lines of volcanoes called the mid-ocean ridge that were pushing the continents apart. We saw, though, there is some differences between the idea of continental drift and plate tectonics. That continental drift really is the idea that the continents randomly kind of float away or drift, whereas plate tectonics, that mid-ocean ridges are pushing continents away. So, let me remind you how these videos work. If I went too fast, you can always hit pause or rewind a section or watch a whole section away. If I'm going too fast again, you can also just take a break and come back and watch the whole thing over again. But always remember to keep moving forward.